Today you're going to be taking some fun doodle notes about the life cycle of a star. The first thing you need to know is that all stars originate in the stellar nebula, which is a giant cloud of gas and dust that's located in space. And here is an illustration of a stellar nebula. The processes that we're going to be looking at today apply to 90% of stars in the universe, which are called main sequence stars. And in those main sequence stars, hydrogen or H atoms fuse to form helium atoms in the core in a process known as nuclear fusion. So hydrogen atoms fuse together to form helium atoms in the core, creating nuclear fusion. This is how stars give off light. And how do scientists know the exact lifetime of a star? Well, that depends on the size of the star. Speaking of the size of a star, an interesting fact is that the largest stars have the shortest lifespan. So the larger the star, the shorter its lifespan. The first series of the life cycle of a star that we're going to look at is the massive star. So when this larger star emerges from the nebula, it begins to expand and cool. Now we're looking at the biggest type of the star in the universe, and this is known as a red supergiant. You probably guessed that the red supergiant glows red. This red supergiant eventually ends in a supernova, and a supernova is the death of a giant star. This occurs when a star has run out of energy and it collapses and explodes. The supernova can leave behind one of two things. The first is something we've all heard of before: a black hole. When the supernova leaves behind a black hole, it leaves behind an area that does not have a surface. And the force of gravity is so strong in a black hole that it even absorbs light. The next possible effect of a supernova is the neutron star. A neutron star is a very tiny but very dense star, and it's actually the collapsed core of the supernova. That was all for the life cycle of a massive star. Now let's look at what happens when an average star is born from the stellar nebula. Our local star, also known as the Sun, falls into this category because it is a small star. Average stars create red giants. Just like the red supergiant, the red giant glows red. Throughout the life cycle of a star, the star expands and cools. And as I mentioned before, the red giant will glow red. As average stars start to die, they create what are called planetary nebula. And this is an expanding shell of gases that are shed by a dying star. And also, I forgot to write down the interesting fact in this area of the paper. So I'm going to tell you what it is. So, fact, stars are actually plasma held together by the force of gravity. After the planetary nebula is formed, a white dwarf appears. That is the leftover center of the nebula, and a white dwarf is about the size of Earth. After an average sized star has died, it leaves behind a black dwarf. An important fact that you need to know is that stars range in color depending on how hot they are. The hottest stars are blue in color. I feel like this lighter shade of blue is a little easier to see. The next level of temperature of stars are white, followed by yellow stars. After yellow stars, we have orange stars. And remember, we're going from hottest to coolest, so we have blue as the hottest, white, yellow, orange, and finally red stars on the coolest end of our spectrum. This information is very important for what we'll be looking at tomorrow with star diagrams.